Hello everyone, today we're going to explore another new large language model that's enabled with vision features. We should call this a multimodal large language model. Ovis is a novel multimodal large language model (MLM) architecture. This is part of a trend of embedding various capabilities into language models. We've seen many recently released language models that can process images and have vision features enabled. Ovis is a bit different from other vision models. It has the basic vision model features, and as you can see in their diagram, they're using both vision embedding and texture embedding. What this means is that when you input an image, like this example of a cat, and ask questions about it, it won't just tell you it's a cat or give simple answers about what kind of cat it is or its color. Instead, it will describe the texture of the materials in the image. For example, it can identify the fur on top of the ears and the fur as the outer layer of the cat. Rather than just telling you this is a cat or giving basic answers, it provides another dimension of information compared to existing vision language models. As you can see in the other part of the diagram, the visual tokenizer separates different parts of the image. You have the ears, the head, the forehead, and other parts of the cat. There's more detailed analysis of each part of the image, describing the visual and textural aspects of the input. This language model is specifically trained for visual and textural input. Typically, other multimodal AI models are only trained for visual input and haven't embedded textual information together in one model. While we can't call this a breakthrough in language models, it is embedding multidimensional knowledge into a single model for image processing. Let's try this out in our video. Before we do, we've seen some benchmarking of Ovis compared with GPT-4 and ChatGPT 3.5. Ovis falls under the open source category and has a very lightweight parameter size of 9 billion rather than the larger sizes that can't run locally on machines. We're seeing that its performance is pretty good for an open source vision model. It claims to outperform others in most benchmarks, and even where it doesn't outperform, it's very close to the top numbers in the industry. For example, in MMBENCH 1.1 and the AI 2D benchmark, it's very close to the top industry numbers. Let's try this out. First, they haven't released any quantized models yet at the time of this recording. It's a very newly released model. For installing in LM Studio or Llama, or for other local PC usage, we might have to wait for the quantized versions of this multimodal language model. Currently, they have the Hugging Face space available for testing these models. I'll share this link so you can try it out and see when it's released. Once they release the quantized version of this model, we can download and install it locally to play around with it on our PCs. Right here, as you can see on the demo page in Hugging Face, they have a few examples you can play around with, and you can also upload your own images to ask questions about. For this example, we have an image with two circles. The prompt is asking to find the areas of the shaded regions. Let's see what the answer will be. We'll press send and wait for the response. We'll also test other images later. Here's the answer to the first question about this image. It's actually creating the formula to calculate the shaded area of the image. It explains very clearly, step by step, how to do the calculation of the shaded regions. The first step is to identify the dimensions. We see that the circle is 20, so the radius r is 10, and the diameter of each smaller circle is 10 because each of their radii is half the size of the larger circle, so the radius of those inner circles is 5 units. It also creates the math formula in the next step to calculate these areas. As you can see, there are more explanations in step 3 as well. Here, we get the reasoning for how it calculates using the two formulas. At the top, you get the areas of the large circle and the small circles, and it's able to process that afterward in step 4. So approximately, the area is calculated using this formula here. After all this, the final result is 157 square units. That's the shaded area of those regions. Now, I can say this is pretty cool. It combines mathematics, logic, and vision capabilities, resulting in a more complex AI response than what we've seen in previously released vision models. The next one is going to be a diagram or design model, a diagram of an AI model. I assume this is also the Ovis design diagram. Let's ask this question. Explain this model to me. This is a simple text prompt. It doesn't need to be too complex. So we pass this image of the diagram and let's see what response we get. We have other AI model files as well, and I can also test other design diagram images. We'll pass those images and see how it responds. Okay, let's take a look at the generated result for this one. Here, it's able to show you all this information about the diagram of this AI model design that we uploaded on the left. It shows that visual and textual data pass through to understand the explanations of that data input of an image. Then there's visual embedding, textual embedding, and integration of both transformer architecture and vision transformer, which combines the attention mechanisms of the multi-layer model. The output of that is the generated response to the analyzed image. So yes, it's able to understand what's going on in the uploaded image here. That's pretty cool. If someone has an AI model research paper and they don't quite understand what's going on in the design diagram, they can capture those diagrams and ask questions here. So let's say I ask the same question, but with a different image. Right here, I'll delete this image first and put another one in. I'm uploading another AI model. This is the recently discussed Depth Crafter for diffusion model image processing. So let's ask the same questions about this new image. This will be something that's not in the example samples, but we can use another image with similar questions and see how it performs. Okay, the response here is pretty well defined for all the steps and overview data input. But it looks like this is the same response as the second example we just did because, as you can see, there's the visual and textual data. But again, I'm uploading this image for analysis, which is the depth crafter. It doesn't have the transformer architecture in this one. Actually, it's using the diffusion UNet, so I guess it's not clear what we have, or it still has the memory of the previous image stored in the token. Let's try again and see if this is really just a dummy answer from this model, or is this model actually not working, just pasting a conceptual hard-coded response each time we press enter. Hopefully, it's not those hard-coded answers that we get each time. So again, I'll ask the same questions about this image, which is again the Depth Crafter model's design diagram. So, okay, that's better. I was worrying if this was a joke, like a responsive model or something like that, using a closed API and pretending to be their own AI model. I was thinking that even if I used a different image and it still gave me the same answer as the second example, maybe this was a fraud or some fake large language model. But now it's proven that those previous answers were cached in the last example's embedded image. So right now, we have a new fresh chat history. It's able to process the new image and tell me that this diagram is of Depth Crafter, a deep learning framework designed for video denoising, utilizing combinations of clip encoding and diffusion UNet and denoising score matching. Here's the detailed breakdown. It's able to tell me each breakdown really well. So the clip encoder, diffusion UNet, we're not just going through those large titles, we're going into those details first. As you can see in the overview of the diagram, we have those parts mentioned, clip encoder, diffusion UNet as well. And it has two stages of video processing. So right here, you see that stages 1, 2, and 3. It's able to tell us what's going on with the diffusion UNet processing, what kind of formula it's using to process each image frame in the videos, and also able to understand what this diagram of the AI framework is used for. So this deep learning framework is used for video processing to measure the depth map of the input videos. Right here, it's able to tell us that this model effectively denoises video clips by leveraging clip encoding, diffusion UNet, and denoising score matching to enhance the quality of video data. So yeah, that's kind of right, but it's too general. I was hoping it would show us a response about the depth map and something related to that topic, but, well, this is good enough. This large language model understands the formula and how the features in this diagram are processed by passing data through each module in this overview, and it has thoroughly described everything as well. So yeah, check this out, guys. This is a pretty cool new vision model, not only for artistic ways of tracking objects like Florence 2 or lava vision models, tracking objects, doing segmentation, those very general kinds of vision models. And this one is more enhanced in the synthetic way of providing more information about an object. In the last video, we talked about LLM 3.2 as well, which is able to do more synthetic data on each input image. So we're looking forward to newer vision models that have this capability, and that's going to be more advanced for language models rather than just doing text to text. So yeah, check this out, guys. I'll see you in the next video. Have a nice day. See ya.